Hi and welcome to DCO. My name is David Copete. In this video I'll be going over this script that I created, and it's a full tutorial with full explanations. Last time it was a time lapse, so this time let me show you some of the things that we did a little bit different. On this design, there are notches not only on the verticals but also on the horizontals here. So what you'll see is that if we look at these, they are notched, and if you look at these, they are notched as well. That will make it so when you CNC or laser cut it, they will intersect here, and it will be an easy way to fabricate this. So I'll be also sharing how to take your design and use Open Nest with it. This will let you unroll and flatten your surfaces and then put them on a sheet. So I'll be going over those steps here. Let me know if you have any questions, and if you want to download the script, go to my website ComputitionalDesign.com. You'll be able to download this script completely for free so you see how it works. So thank you very much for being here, and let's get into it. Alright, so the first thing we'll do is bring in a circle. So we'll go here to a circle component, bring in a radius, we'll go 15.5. Now we can use this as the size of the design. Let's change this to radius. Alright, so now that we've created the overall size using the slider and using the circle, now let's divide this using divide curve. Now we'll use the circle and plug in the circle as the curve input, and now we can use this count to change the number of subdivisions for that circle. Now when you create a slider, let me show you how to create a custom slider. We'll go from 0, less than 15, less than, let's say 40. And that gives you a slider at 15, and it does the limit at 0 and at 40. So we'll go here. Now we're going to take these and move them up. So let's go to a move component. Use the points as the geometry input. The motion is going to be Z. Why? Because we want to move them up. So we'll use this vector as the motion, and let's add a vector slider. I'll just copy this one, plug it in, and let's relabel these. So now let's connect that. Let's connect those two. Let's use a line segment. So double click, bring in a line segment, start point and end point. This will let us use these points as a start and these that we moved up as the end points. Now if you're not seeing the components like I see them here, go to display, draw full icons, fancy wires, draw full names, and if you want to go and download sunglasses, that's how you'll be able to see the name of the component above. Okay, let's move on. Now we'll see that it creates a line segment between the start of these and the end of this one. Now we can move that like so. All right, the next part, we need to create another set of points that are moved up, and then we use a point attractor to have that pattern change. So what we need to do now is take these points, copy them, and copy the move again. So I'll use these, slide it over, tap Alt, and use this as the input. So it makes another copy, and now this will be height 2. We'll lower it. All right, now with these points, let's create the point attractor. So what we need to do is somewhere along this circle, or now this circle, we need to create a point attractor. So how do we do that? First, we need the circle. So we'll create a circle fitting the points. So that'll create a circle right there. Now we need to extract a point from that circle. So let's go here to evaluate curve. And there are other different ways we can do this, but we'll use evaluate curve on this example. The circle is going to be the input for the curve, and the parameter is going to be, if this were 0 to 1, where along that curve would you extract the point? So we'll go here to 0.500, and then reparameterize the curve input. This way, when I move it around, it goes from the beginning and then all the way around. So now we have a way to react to just one specific point. Now we need to create the point attractor, which would be where this point, how far this point is to each and every one of those points. So we need to connect them again. And this time we'll use the same line segment, which is start and end point, starting at this point, which is the point attractor, and ending at these points. As you can see, they all change in size, and that's what's going to make the change in height happen. So now notice that this length is shorter than this one, and therefore the height of it is going to be shorter than this one. So if you see that it will change as soon as I move the point, and that's how we create a point attractor, or the ability to have the pattern change referencing one point. All right, so let's take this and the length of every one of those line segments. So we'll go here to length. So now that what we need to do is take the length of all of these and create a move component and move all of these points up by the corresponding length. So you'll see here that this length is going to be shorter than those lengths. So if we go here to move, which points? These that we moved up. The motion in which direction? Up in the Z direction, using the length of those. Notice that we don't have any control. We're just using whatever length that is going to be the height. To change that, this is where we can take any set of numbers and change them to be a smaller set, basically scaling them down, but using math or using the components here. So how do we do that? We'll take the length, we'll remap the numbers, then we need two more components, bounds. This gives you the largest and smallest number. And target is going to be the minimum and maximum number. So let's go here to construct domain. Let's start and end. Let's go 1, 0 less than 2 less than 3.000. We'll create two sliders here. Change the minimum and maximum. And that's going to be how far it's going to move them up and down. So we'll use the domain as the target. Now we have 18 remapped numbers that we can use as the Z values. So notice that we basically scaled them down by a lot, so we can still scale them up more. So let's go maximum 20. See that you can change the maximum height and the minimum as well. Let's go here to 50. Okay, so let's hide part of the beginning portion of the design. And now what we need to do is connect these and those, but there's still another portion that we need to do. We need to scale these values to be larger. So right now, they're just at this location. We actually need to scale them because they can't be aligned. They need to be wider. But here's the trick. So before that, let's just connect them so you can see kind of where we're at. So we'll take these points, or the ones below, connect then to these points. So let's do that. Let's take these points, go to Interpolate Curve, between these. So we'll go here to Graft, Tree, and these. And we'll have to graft both of those. Then graft the next set, which is going to be this one. So what I'll do is I'll bring both of these over here and add the next set. It's this one. But notice it just creates a straight line, and that's not the idea. The idea is for these two also to go out and splay out. So what we need to do is scale up these two this pattern here. So what we'll do is, well, just disable preview on this. Now we need to get the center point of that circle. We'll take this circle, go to an area component, bring in the midpoint, and then have this midpoint move up and down. That way we can control where the scale happens. So we'll go to move this point up in the Z direction. And I'll go 15.5. So we have a slider between 0 and 100. Now that's going to be the point that's going to be used to scale this pattern. So we'll move this over here. Go to Scale. Bring this pattern using the center point. And the factor has to be more than 1. That way it creates one that's larger. So let's go here to 1.0 less than 1 less than 2.500. So when you scale it by 1, it stays the same. When you scale it by more than 1, it scales from this point. And that's why we have the ability to move that point up and down, because if you move it up, it scales down. If you move it down, it scales up. And also we can use these here to create a interpolated circle. Then if you go here to periodic, set boolean true, it closes it. And if you bring an area component, it won't give me the midpoint unless I do a patch and then an area component. Then maybe this center point can be the center point of that. That way we don't have to move it up and down. So you're saying there's different approaches we can take, and this one is tying it to the geometry that we already have. Okay, so why do we scale it up and down like this? Well, we actually also need to move it up. So we need to take this, disable preview, take this, and move this up in the Z direction. Then use a different slider. So 15.50, and then disable the preview on this. So now this becomes the new scaled portion. Okay, so now let's connect them. We'll go to preview here. Now we're going to not plug these in and plug these in. Notice that now when we scale this up, this happens. And also that if we create a new copy and actually incorporate the first set, this one first, it'll work out like this. So let's disconnect all and connect the first one, the second set, the third set, the fourth set, and we can move this up as well. And when you create an interpolated curve, we can also change the degree in which it happens here. Okay. So notice that at this stage, we've splayed it out this much, but now we need to bring it back to a set here. So what we need to do is then take these not those, these set of points, and then move them up and have them come back around to it. So what we'll do is we'll take this and we will create another move component, move those points up. This is going to be height 2. And this is going to be height 3. Why? Because that actually brings it all the way up. Okay, let's bring this over. And use a new set. So copy the grafted component and use Shift to add this other input. Now we need to take this and move it up again. So I can copy this. This is going to be height 4. But this will actually be with this one, and it will be a smaller number. So now let's do this again. Hold down Shift and add another input. So let's decrease the let's increase the scale. The minimum and maximum maybe are too much. and then shifting this up. So height 1, this one. Height 2, this one. All right, let's decrease also this one a little more. Increase the height on this one, max. Okay, great. So we got most of the design down here. Let's disable the preview on most of the points so we can see the form. Okay, so now we'll take these line segments, these curves, and let's offset them. So we'll go here to offset, and since they're planar, it's going to use the plane and offset them using that reference. So let's offset it to one side here. We'll go 1.50, use this as the offset. Now we're going to loft together those two. Here's the thing. We need to use a graphed component using this one so it matches using the offset curve. That's something that I've noticed needs to be done. So now with the offset amount, so it's going to be section depth. But here's the other thing I like to share is sometimes you want to offset them to the outside and also to the inside. So if you go like this, 4.32 in the negative direction, decrease this number, and then use this and the other offset, basically making it so you offset from the center. And this is going to make it useful, so that becomes basically the center line. We're going to be doing the same thing with the surfaces to create some thickness to it. We need to extrude or move perpendicular to the surface and then extrude the other way by 2. So we'll go here to move, use these as geometry input, use amplitude to move, and now whatever we use to move the amplitude by, we are then going to multiply by 2 and then go in the negative direction to extrude the surface that we just moved. This allows us to then extrude in the same way that we are offsetting from the center. We're also extruding from the center using amplitude of 1.5. But notice it's 1.5 and 1.5. So technically it's 1.5 divided by 2, which makes it 0.75, 0.75, and a whole of 1.5, which is the true overall size. Same with this one. If we offset this way by 1.65 and this way by 1.65, well, it would actually be divided by 2, so it would be the true size. So this section offset will also be divided by 2. Now let's move this over, make sure it fits. Just organizing some things here. All right, let's move into this here. If it's half of it this way, and then if it's half of it that way, we'll also do this. Now we can go back and look at the subdivisions. And now we can see that if we want to increase them, we start getting a bit of a different look, and we can change the location of where the point attractor is done. Okay, at this stage, I'll disable the preview on this and the loft and go back to the center curves. So that's what we used at first. Now we're going to use the loft component, loft together those line segments by flattening them, and it's not going to close it unless you go to right click, loft options, close loft, commit to changes. Now we have a surface we can work with. What I like to do is create a contour array vertically. So let's go to, and there are different ways we could achieve that. We can also create a copy of this plane and intersect it, which is what I did on the last one. But on this one, we'll use contour for this loft. Direction, well, we want it to go up and down, so unit Z. Distance is going to be 15.5. And the location it starts is down here, but actually with this one, I'll bring in an area component and start from the exact centroid of that form. And then change it if we need to. Okay, so now that we have this, let's disable the preview on most of this and bring back some of these forms. Now we're going to take these and offset them to the inside. So I'll go here to offset, curve, go to the negative component. I want it to offset to the inside, and I'll go to 1.5. Now we need to turn those into surfaces, so boundary surfaces. And then using graph tree so the offset can work. Okay, with those surfaces, now we need to extrude it up and down. So using the same technique that we used here, we can take all of this, copy it down here, and use these surfaces to move it up and down and extrude it relative to the center. So now we have these intersecting sections that we can change if we want to. If we don't want them to go all the way through, which we do, so that way we can connect it, And then we also want to be able to change the depth here. Two. All right. So now what we could do is subtract one from the other. So let's take the boundary or Boolean difference, solid difference, and subtract the outer frames and flatten the input for the ring or this section. Now let's see, creates 33 different ones here. Now we can disable the preview on this because these become the new set. And if we want different here, let's go to 20 and see that it changes the location of them. Now the trick on this is that every time you change it, when you have too many subdivisions, it gets so heavy on the computer that it's really hard to see the changes. So in some of these cases, I will do this. Data dam. So if there's a lot of changes on the verticals, I'll have to click on play for this to change so I can see where they're located. Okay, I want all of those. Then you press the play or the data dam, and you'll see that it'll actually run the solid difference. And it's going to take a little bit here, but that's the idea, is that you don't have to wait to see what you want to do. You do that first, and then you hit the play, and then it does Boolean difference to all of those. The reason why that matters is now we need to bring back these, and now we need to offset those, and you'll see why. This is a bit of a, it seems like a strange thing to do, but if we offset them to the outside using a small number, it doesn't have to be anything bigger than, let's say, like 0.1 or something. Now where those new boundaries are, boundary surfaces, where those intersect with this, I want to extract. Why? Because now it's a larger surface, so now it'll work for sure. And I will go to intersect, physical, brep, using these as the input, flatten the input. Now flatten, actually grafted might work. There it is. So it extracts the curves or the line segments from that. So we can now, on the next few steps, create a sheet for a CNC or laser cutter. So you can arrange these. So these become surfaces, boundary surfaces. I'll go here to this one. These become the segments that we need to put on a sheet so we can laser cut. So that's the next steps. It's taking the data that we have and further making it so you can fabricate it. So the segments, verticals, and surfaces. All right, what we're going to do now is put this on a sheet so we can print it. What we need to do then is come back here to those surfaces. Now they have been created, but I think we need to still update this. And let's say we want more subdivisions. Then let's go and change that. Let's change the divisions. Let's go to 24 here. Let's change the size. The scale, let's go 2.5. Let's change the size from the offset here. Now the ring on the inside, let's change the size to that as well. Now we have the scale for the form here. We can move this . There it is. Something like that. Now let's go down here and let's press the play for the data dem. This can be and then let's change this back. Let's say this is going to be the design. Now let's finalize that. And when we extracted these surfaces, now we need to take these and put them on a sheet. So what we'll do is, if you don't already download OpenNest, it is free. And once you download it and install it, you'll have this portion of the Grasshopper. You'll have this tab. And what you can do now here is take your surfaces or your objects, and now we can unroll them or project them. Now what it does is it creates a surface perpendicular or along the same surface that it creates that segment, and it projects it to the ground. Now what we need to do is take these projected items and we need to pack them into a sheet. So let's bring this back so we can see the design. Now let's create a rectangle that's going to be the boundary of where those can be located. Let's go here to rectangle. I'll create a rectangle here and just give it a specific size. Now I just want to make sure that it fits my segments. Now let's go here to OpenNest. The rectangle is going to be the sheets. The geometry is going to be the projected objects. I'm going to take a second here and it's going to populate the sheet with those objects. Now we do have to flatten the input. and add a few more things. So far here we have 2 sheets. Now it does place them there, which is great, but we now need to make a few adjustments. For rotations, on this one, I think by default, it's going to be 4. We change it to 2. This will make it so it only rotates it 2 ways, and it actually packs it a little bit better. Since we have so many objects, it's going to take a little bit. If you do it by 1, it only packs them evenly. Let's see if this one gives us a better result. A little bit. Go to 3. And then 4. From what I'm seeing, the either 1 or 2 is the best. With that being said, it really depends on the sheet size, but this will help you pack that without having to do it manually. Let's go to 300. Basically, we're just increasing the size of the sheet so they fit. Now there are other things here, like tolerance. We'll go to 0.1. It'll be how close it'll pack them.